SpaceX solve a certain software problem which is caused by spaceflight, and that is the high risk of corruption of processes and memory through bit flip. It's an interesting case study, and I think it illustrates really well how Elon Musk and his companies, in particular SpaceX and Tesla, are operating at low cost and software driven, and therefore also enable high iteration rates, debugging, and solving problems on the fly. This is the Not Even Wrong podcast. It's March 23rd, 2021. This is Krim Delco for the day. The fund is down 2.8%. The market's down 70 basis points. For the year, we are down 4.5%. The market is up roughly 4%. We're underperforming by 8.5%. So I'm doing a crypto course about blockchain and cryptography and consensus, Nakamoto consensus technology. So in a sense, this course is about the technology and the ideas and the concepts around how distributed systems through voting mechanisms can solve the problem of how to find consensus. And the example that the course gives in the early parts of the course, this is an EDX course, by the way, by Berkeley, very highly recommended. So they talk about the first problems that occurred when computers had to be synchronized in consensus type of algorithms, and that was it was actually the flying in the air, so airline flights and things along those lines. And the problem there was that the decision was made that computers will fly airplanes, and when airplanes are flying, now we're talking airplanes, not space. We will get to space very quickly, but when we have a situation that a craft is flying, let's say, at 30,000 feet, there is a risk of radiation. There are temperature differences, pressure differences, things along those lines. And the risk is bit switch. I mean, there's other risks, but this is the main risk. And how was this solved? It was solved by having several computers and then finding a consensus algorithm to decide if one computer was corrupted, or in technical terms, the Byzantine fault tolerance was found through the communication of several redundant computers that then find the mistaken one and then go from there and fix it and so on and so forth. Now let's get to SpaceX. SpaceX is a company by Elon Musk that is engaged in space flight, and I want to point out two things here. I want to quickly talk about the solution, but the key insight here is not necessarily the solution. It is the ability of SpaceX to solve a problem with low-cost hardware and iteration and software. This is the key. So instead of using radiation-resistant hardware, which is what the space industry has been doing typically, SpaceX has chosen a way of going with commodity hardware, of using low-cost devices and very off-the-shelf type software, also Linux, things like that, C++, nothing fancy, in order to achieve two things. One, in order to be able to build this thing with low cost, but more importantly also in order to be able to hire people from all kinds of different engineering practices that didn't have to have special know-how in dealing, let's say, with radiation-resistant processors. So what SpaceX did instead, so take the space industry prior to SpaceX. I think we've spoken about this even yesterday in the podcast about the conversation with Eric Berger, who wrote the book about the early days of SpaceX. We spoke about the fact that SpaceX's main goal was to lower the launch cost. By lowering the launch cost, they enabled a couple of things. One, of course, lowering the cost, increasing the frequency of flight, increasing the payload, increasing opportunities for other businesses. So there's a flywheel effect, which is actually kicking in as we speak. And the way they lowered the cost is, of course, by enabling relaunch. And this is not necessarily the key of this particular episode. The key of this particular episode is to talk about the application of low-cost hardware that is flying up in space and therefore setting itself up for the risk of bit switches. A bit switch is when, in particular, radiation, also temperature, but particularly radiation can cause that. So you have, let's say, a certain processor which in binary is reading, let's say, 1000. And a bit switch could be that the processor, instead of reading 1000, is reading 1001. And this one bit switch can cause enormous amounts of mistakes. Actually, in this course, they show the Ariane 6 flight from 1996, the European Space Agency flew a rocket and failed because of a bit switch, apparently. So what happened is they read the wrong number. The wrong number was then propagated throughout the system, and mistakes were made. The rocket basically thought that its positioning is Y versus the actual positioning was X, and that caused the whole damage. So in order to avoid that, SpaceX is using a consensus algorithm, and this is why this was even used in this course. It was just, they were trying to make the point that cryptographic consensus, which is basically virtual consensus, so consensus between digital agents, computers, processors, so that kind of consensus can be achieved in algorithmic ways. It can be done, of course. The blockchain is another example. It's not being used in SpaceX in particular because it's energy consuming, time consuming, and things like that. But there is a consensus being used, and this is the key. The consensus is being used, and again, for this purpose, for this particular purpose of this in this episode, I don't necessarily want to talk about the consensus algorithms and all these things. I want to talk about just the fact that SpaceX is using low-cost hardware and continuous integration. This is another amazing thing, and now finally, more than a year after my conversation with the CEO of GitLab, I remember, I forgot his name, his name eludes me now, but Dutch fellow, he spoke to me about Boca Chica and SpaceX. And I always wondered, why does the CEO of GitLab, what does he have to, why is he talking to me about Boca Chica? Well, now I know. Continuous integration is one of the key aspects of GitLab. It's one of the key differentiating factors of GitLab. It's continuous integration. And he must have been in Boca Chica helping SpaceX implement GitLab technology to do that. So continuous integration is, I think in layman's terms, I would say it's just simply that you use low-cost hardware, you use software, and you iterate, debug, and get very quickly to the core of problems and solve them, and therefore create a system which is robust and can withstand problems, etc. So the conclusion here is that we have a company which is doing very, very high-end stuff, rockets. The company is exposed to high-end problems such as bit flips because of radiation. Before SpaceX, this problem was solved with bit switch resistant, or radiation resistant, hardware. Very expensive, very difficult to program, very rare to find somebody who can actually program this thing, and very, very expensive. SpaceX is going the other way. Low-cost hardware, commoditized engineering know-how that then gets applied in specific problem-solving, iterative processes within the company, and this is the key to success. And while we're now talking about SpaceX, of course, it is pretty obvious that the same approach is being used by Tesla. For example, the whole self-drive technology by Tesla, it's the same. It's low-cost cameras, algorithmic solutions, continuous integration, even also low-cost software, C++, Linux, those are low-cost solutions. They're not highly specialized software type applications where you have to have very high-end, very, very expensive software engineers. You can use, for lack of better words, off-the-shelf engineers. But I don't mean this to be disrespectful to the engineers. They are very highly educated engineers, but it's just very difficult if there are 10 people in the world that you can hire for a specific software program, because it is so difficult to do because it has so many constraints. That just drives the cost up, and it's very difficult to do business. And that's why the space industry for decades has been so stagnant. And Tesla has broken that, and SpaceX has broken that by using this low-cost approach, low-cost, software-driven, algorithmic solutions, continuous integration. Those are the key words. I've spoken about this several times. I've spoken about iterate and debug. I've spoken about speed. Speed is the key advantage of Tesla and the disadvantage of the competition. So that also applies to the question of how will Volkswagen compete with Tesla. And the answer is the one thing that Volkswagen will have a really hard time, amongst many other things, is speed. And this is a good example, this whole idea of how to solve the radiation problem, the bit switch problem in space flight, how to solve that. SpaceX is using a low-cost, highly iterative, debug-centric approach with off-the-shelf hardware, software, and engineering talent. And this is driving down cost and increasing the rapid rate of innovation. Thank you.